Most people think of the cloud as something abstract, an invisible layer of computing power somewhere on the internet. Application run, files appear instantly, entire businesses operate online. But behind that simple experience lies one of the most complex engineering systems ever built. The cloud is not just servers. It is a massive orchestration system. Thousands of machines, thousands of software processes, all coordinated by hidden control systems. When engineers talk about the cloud, they are usually referring to something more specific. A distributed computing platform that automatically manages infrastructure at enormous scale. Companies like Amazon Web Services, Google Cloud, and Microsoft Azure operate millions of servers around the world. But managing millions of machines manually would be impossible. Instead, modern cloud platforms rely on orchestration software, automation layers that decide where applications run, when servers start, when servers shut down, how traffic is distributed, how failures are isolated. In many ways, these control systems are the real brain of the cloud. They constantly monitor the health of infrastructure. If a server fails, the system detects the problem. Then it moves workloads somewhere else. If traffic suddenly increases, the system launches additional capacity. If demand falls, resources are reduced. All of this happens automatically, often in seconds. This is the promise of cloud computing, infrastructure that adapts to demand without human intervention. But automation also introduces new risks. Because when control systems operate at massive scale, a small mistake can propagate quickly. A configuration error, a faulty deployment, a permissions change. Any of these can spread across an entire system. That is why cloud engineers design systems around one central idea, the assumption that failure will eventually happen. Large distributed systems are not designed to avoid failure. They are designed to contain it, to isolate it, to prevent a small problem from becoming a global outage. Inside every cloud platform, layers of safeguards exist. Permission systems restrict what engineers can change. Deployment pipelines verify configuration updates. Monitoring systems watch for anomalies. Automated rollback mechanisms attempt to reverse dangerous changes. These layers form what engineers call the control plane. The control plane is responsible for managing the infrastructure itself, and it is separate from the systems that run applications. When everything works correctly, the control plane keeps the cloud stable, invisible, reliable. But when control systems fail, the results can be dramatic. Services slow down, applications disconnect, entire platforms may stop responding. And because modern internet services depend on shared infrastructure, the impact can spread rapidly. This is one of the defining characteristics of modern technology. Systems that appear independent are often connected through hidden layers. Streaming platforms, online stores, financial services, communication tools. Many of them ultimately depend on the same cloud infrastructure, which means that deep inside the internet, there are a handful of systems quietly coordinating the work of millions of computers, and most users never see them. But these invisible control systems determine something fundamental: where your data lives, how your applications run, and whether the internet continues working the way you expect. Because in the modern cloud, the real infrastructure is not just hardware. It is the system that decides how the hardware behaves.